The Lewis structure of sulfate plays an important role in the history of the theory of chemical bonding. It is the compound, the ion, which most messed up the thinking of Linus Pauling. So Linus Pauling knew that sulfate was interesting, and he invented a theory by which we could connect bonding to quantum mechanics. And his theory is called valence bond theory. We'll learn a bit of valence bond theory at the end of our course. He invented valence bond theory in the 1930s. The problem is, valence bond theory is very hard to use. You need a pretty fast and pretty big computer. And it really wasn't until the 1980s and 90s that computers were good enough that we could correctly use valence bond theory. So when chemists finally got to solving the quantum mechanical picture of sulfate, they discovered that the structure that Linus Pauling had derived using valence bond theory wasn't correct. The correct one is the one that I've shown here. So Linus Pauling is both part of the problem and the solution. He came up with the wrong solution. It's not totally his fault. It's not his fault. The computers weren't good enough, but he really did stick to his guns that this crazy structure, which is in your textbook, was the correct one. But eventually, using his own theories, we were able to find out that this, the one that I've shown you in purple, is the correct structure. Okay, let's go on to something else. We're going to talk about resonance. So resonance. And we're going to look at the 3D Lewis structure of the nitrite ion, NO2-. 3D Lewis structures. Do I begin? This is a central atom molecule. Do I begin with VSEPR or with formal charges? Put it in chat. Do I begin with VSEPR or formal charges? Put it in chat. The answer is VSEPR. And which one is the central atom? N or O? Which atom is more electropositive? Put it in chat. N. So N is the central atom. And what is its steric number? NO2-. What is its steric number? Nitrogen has 5 electrons. Oxygen donates 0. There's a minus charge. That's 6 electrons divided by 2. Steric number is 3. And therefore put in chat the name of the shape of the nitrite ion. Put it in chat. The shape is, remember, there are only 2 atoms, peripheral atoms. So it's not trigonal planar. It is, put it in chat, bent. And what is the thing that most students will do, which will not be a good thing to do at this point? What is it that you're probably even feeling it right now. What is it that you should not do right now? Put it in chat. What should you not do right now? Draw the bonds. You don't know the bonds. You know the shape. You know what's bent. You know the 2 oxygens are like this. To find the bonds, we need to use formal charges. So, let's see that. Nitrogen has 4 bonds. What's its formal charge? Nitrogen with 4 bonds is like carbon. That's nitrogen. Carbon has 1 electron less. Nitrogen plus. Nitrogen has 3 bonds. Its formal charges, put it in chat. Nitrogen with 3 bonds, its formal charge is 0. Nitrogen with 2 bonds, what's its formal charge? And the answer is minus 1, because it's like oxygen. Oxygen with 2 bonds, what's its formal charge? And the answer is 0. Oxygen with 1 bond, its formal charge is, put it in chat, minus 1. And we have to put all these pieces together and figure out its NO2-, put in a number of bonds that gets the right answer. And I'll give you 30 seconds to try to figure out a solution that works. And don't draw the lone pairs now. Just put the bonds in. Figure out a solution that works. It has to be that the sum of the formal charges adds up to the overall charge of the species, which is minus. 20 more seconds. 10 more seconds for you to come up with your answer. And by the way, there's 2 answers that are correct. Okay, so the solution, one solution is this. 2 bonds of nitrogen on one side, 1 bond of nitrogen on the other. Oxygen with 2 bonds is neutral. Nitrogen with 3 bonds is neutral. Oxygen with 1 bond is minus. That's one solution. The other solution is very similar. What's missing in our solutions? Put in chat what's missing in our solutions. 2 words long. What's missing? The lone pairs. Always put the lone pairs in after you've drawn in the bonds. And by the way, we know these are correct solutions because you sum up the formal charges and they add up to the charge of the species, NO2 minus. And both of these solutions are equally good. They are both equally right. And the actual electronic structure is a combination of the two. There's a word that's mathematicians like to use, linear combination. I'm not going to tell you what linear combination is, but it's a combination of the two. And this is called resonance. Notice that we use this symbol. That is not reactions. Reactions are written like this. A reaction arrow could be a single arrow or a double arrow, but it's never like in resonance. Resonance is not a reaction. And the rule for resonance is in resonance structures, in proper resonance structures, no atom moves. The only thing that moves are the electrons.